Hello students, welcome to YourPedia Education. My name is Arun Pathania and today in this video we are going to solve an NPTEL assignment question from the subject of highway engineering. This question has been taken from the page number 291 of this particular book, in which all the NPTEL assignment questions for the branch of civil engineering has been compiled in an orderly fashion. So let's just read the question and try and solve it. So this is your question in which the design speed of a highway is given and there is a horizontal curve of radius 200 meter on that particular highway, and the safe limit of transverse coefficient of friction or the lateral coefficient of friction is 0.15. So we have to calculate two things. First, we have to calculate the super elevation which is required to maintain the speed, which means we have to find the design super elevation for maintaining 80 km per hour speed on that particular highway. And then second thing, if the maximum super elevation is of 0.07 cannot be exceeded, which means that if this design super elevation comes out to be greater than 7%, then we can't provide the design super elevation. We have to provide the super elevation is equal to 7% only, because we can't exceed the maximum value. And if we can't exceed the maximum value, this particular speed is now not safe on this particular highway on this horizontal curve, because the super elevation is not enough to prevent it from the lateral skidding. So in that case, the maximum allowable speed on this horizontal curve we need to find. What is that maximum speed that still can be allowed by providing 7% super elevation? So these are the two things we have to find. We have to find the design super elevation and we have to find the allowable speed. Okay. So the data just I have written over here. Now let me tell you the formula that we are going to use. Now if our road is or our pavement is leveled, there is no super elevation provided over there, then only the lateral friction is going to oppose the centrifugal force. Okay, and only the lateral friction is going to prevent the lateral skidding. So in order to prevent the lateral skidding, the lateral friction mgf should be greater than the centrifugal force mv square upon r, where r is basically, let me represent it by the capital R, is basically your radius of the curve. Okay, radius of the horizontal curve. Now if I cancel m from both sides, I get for no lateral skidding, my coefficient of lateral friction should be greater than or equal to v square upon gr. Now this v square upon gr is also called as the centrifugal ratio. It is the ratio of centrifugal force by the weight of the body. Okay. Now coming on to the next case. So for the limiting case, for the limiting condition, my coefficient, lateral coefficient of friction should be equal to v square upon gr. Here the v that I have taken is in meter per second, but mostly the design speed is given in kilometer per hour. So I converted it into kilometer per hour, and the term I also substituted the value of g as 9.81, and I got this particular formula that f should be equal to v square upon 127 r. But if super elevation is also provided, generally what we do is we provide super elevation on the horizontal curve, we raise the outer edge with respect to the inner edge, and in that case super elevation also helps in resisting the centrifugal force, and in that case the formula becomes that E plus F must be equal to or greater than v square upon 127 r. But when we need to find the design super elevation, we consider that there is no contribution of the lateral friction on that particular horizontal curve. So we consider that f is equal to 0. We want to make the horizontal curve safe only on the basis of super elevation. Only with this help of super elevation we want to avoid the lateral skidding. We don't depend upon the lateral coefficient of friction. So in that case, F must be totally avoided. It's considered as 0, and that will give me the value of E design super elevation. But also on a highway, you know, in India we have this mixed traffic condition. Not all the vehicles are moving at this same speed on the highway. So in that case, it's very unreasonable to take the highest speed for the calculation of E design. So what we do is we take v is equal to 0.75 times of the design speed of the highway. We don't consider the overall design speed or the highest value, we reduce it by 25% and we only consider 0.75 times of VD. So in order to find the design superelevation, these are two considerations or the assumption that we have to take into account. So the formula now becomes that the E design is equal to 0.75 times of VD whole square divided by 127R, which we can write as VD square upon 225R. So from here, if I substitute the value of VD and R, I can find the value of E design for my given speed on that particular horizontal curve. So let us just find the value of E design. So E design becomes VD is 100 into 100, or I think 80. What was the value of VD? Sorry, it's 80 kilometer per hour. So we have to put 80 into 80 divided by 225. And what is the value of the radius of the horizontal curve? 200 meters. So I'm placing R as 200. So this gives me the value of design superelevation as 0.142, which I can also write as 14.2%. So the design superelevation that is required on that particular horizontal curve, if we want to allow a vehicle with the speed of 80 km per hour, is 14.2%. Okay, so the answer to the first part is 14.2% or 0.142, but in the second part it has been given that the maximum superelevation is 7% and we can't provide a superelevation more than that. So what we have to do, E provided on the site will be 0.07 only, 7% only, because we can't exceed the maximum value. Now in this case, we have to find what is the maximum allowable speed. Now the maximum allowable speed cannot be 80 km per hour. It will be less than that value because we have not provided the 14% superelevation. So what I do, first I find what is the requirement of the lateral coefficient of friction, because in actual condition, in reality, some lateral coefficient of friction will also be there. While finding the value of E design, I assumed F to be equal to be 0 and I assumed V is equal to 0.75 times of VD, but in reality V is equal to VD and F has some value. So I have to find what is the required value of F, and if that F value comes out to be less than the safe value of lateral coefficient of friction, which has been given as 0.15, then our design is fine. We can go ahead with this 7% of superelevation and we can still allow a speed of 80 km per hour on our road. But if this F value, required F value, comes out to be greater than the safe value, in that case now we have no other choice. Since E is also fixed, F is also fixed, now what we can do is we can't increase the left hand side of the equation. Of this particular equation, we can't increase the left hand side value. So what we have to do in order to make the design safe, we have to decrease the right hand side value of the equation. So how can we decrease the right hand side value? By changing the R, by increasing the radius of the curve, but in the question it has been mentioned that the radius cannot be altered. So what is the last choice that we have? That we have to decrease the velocity of the vehicle. Allowed velocity should be decreased, design speed should be decreased. So in that case, our centrifugal ratio will decrease and will come within the safe limits. So that's what we have to do. So let's just first check what is the F required. So using the same equation, we have E provided plus F required should be equal to V square upon 127R. In this case, we are considering V as VD only. Okay, we are not considering 0.75 because in reality it's VD only. It's not 25% less than that. Okay, so from here I put the values, I substituted the values, and I get this is coming out to be 80 into 80, 127 into 200, which is equal to yes. So from here I can get that the F required is 0.182. Now you can see this F required value is 0.182 and the F safe value as given in the question was 0.15. So this is greater than the F safe value which is 0.15, which means ki this is not possible. The F that is required on that particular horizontal curve with this much of super elevation in order to allow a speed of 80 km per hour is more than the safe coefficient of lateral friction. So we can't go ahead with this design. We have to decrease the value of right hand side of the equation, because we can't increase the value of the left hand side of the equation now. And what is the way that I have told you? We have to reduce the value of V. So what we'll do is, now E provided is also fixed with us, and F maximum is also fixed with me. So now I have to put V as V allowable and use the same equation, and E provided is 0.07, F max is 0.15, and now I can easily find the value of V allowable. So this is coming out to be this. So this will be 0.22 into 127 into 200 under root will give me the value of V allowable velocity, allowable speed on that particular stretch. So this is equal to 5588 under root, which is equal to 74.75 kilometer per hour. So let me just say ki 74 kilometer per hour is my allowable speed. So as you saw in this particular example, the design speed of the road was 80 km per hour. But in order to allow that 80 km per hour on the horizontal curve, we must have provided the super elevation equal to 14%, which is not possible because it is greater than the maximum value. So we have to limit our super elevation as 7% only. Now when we limit the value to 7%, we saw that what amount of lateral friction is required in that case in order to make the design safe, and that value of lateral friction comes out to be greater than the safe value. So in this case, what we have to do, we have to reduce the value of velocity, and the value of speed that I have reduced on the horizontal curve is 74 km per hour. So on the leveled stretch of the road, on the straight stretch of the road, driver can move at 80 km per hour, but on horizontal curve there must be some signboard or speed limit board that must be placed over there, which will signal the driver that they have to reduce their speed less than this particular value. Otherwise there is a very high chance of lateral skidding of the vehicle, which is not safe. So in this way we design our road. I hope this this example is clear to you, and if you have any other doubt, you can just write that in the comments and we will try to clear that as soon as possible. So that's it from my side. Thank you very much, and I wish you all the very best in the future.